and welcome back to our YouTube channel. Today we have an exciting topic lined up for you, the continuation of IUPAC naming of alicyclic compounds, specifically focusing on compounds that also have functional groups. In our previous video, we have covered the fundamentals of naming simple alicyclic compounds, and now it is time to take our understanding to the next level. If you haven't watched our previous video on this topic, I highly recommend checking it out to ensure you are up to speed. The link of the previous video on alicyclic compounds has been given in the description below. Throughout this video, we will walk you through step-by-step examples of alicyclic compounds, highlighting the incorporation of various functional groups. By the end, you will be able to confidently name a wide range of alicyclic compounds, no matter how complex they might appear. Don't forget to leave your questions and comments below. We love hearing from you. Now, without further ado, let us start exploring the continuation of IUPAC naming for alicyclic compounds having functional groups. Enjoy the video. Before going to explore the IUPAC naming of alicyclic compounds containing functional groups, let us recap the geometrical representation of alicyclic compounds, which is commonly done using line angle structures. So, representation of alicyclic compounds by simple geometrical figures. Let us see here. This is an alicyclic compound named cyclopropane because it contains 3 carbon atoms in the ring. So it is cyclopropane. It is represented by a simple geometrical figure or diagram like this. So in these representations, carbon atoms are depicted as vertices. Okay, so these 3 carbon atoms are depicted as vertices here, and carbon-carbon bonds are implied rather than explicitly drawn. Okay, so hydrogen atoms attached to the carbon atoms are usually omitted, and functional groups, if present, are included in the diagram. So this is the simple geometrical figure showing cyclopropane. Okay, next one, in this ring 4 carbon atoms are there, so it is cyclobutane because no multiple bonds are there between the any 2 carbon atoms here. So it is depicted as like this. So it is cyclobutane. Some more examples you can see here. This is cyclopentane because it contains 5 carbon atoms in the ring. So it is represented by the geometrical figure like this. Next one, cyclohexane is represented by this geometrical figure. Next, this is an alicyclic compound. So let us name it. Here 3 carbon atoms are forming a ring and there is a double bond between the 2 carbon atoms here. So when 3 carbon atoms are there in the ring means it is prop, and ring structure is there. So it is cycloprop. Double bond is there, it is ene. So cyclopropene. So in the geometrical structure or figure, we must show the double bonds. So it is the structure of cyclopropene. Next, the same way, it is cyclobutene because double bond is there here. We have to show the same double bond in the diagram also. So this is cyclobutene. Now let us explore the IUPAC naming of alicyclic compounds with functional groups. Alicyclic alcohols, amines, aldehydes, ketones, etc. are named in the same fashion as corresponding aliphatic compounds by prefixing the word cyclo before the name. Let us see some worked examples here. This is an alicyclic compound containing OH functional group, and we have to provide IUPAC name for this alicyclic compound. In this compound, 5 carbon atoms are formed a ring here, so the root word is pent. Only carbon-carbon single bonds are there between the carbon atoms in the ring, so the primary suffix is ane, and these carbon atoms are forming a ring, so the primary prefix is cyclo. And coming to the secondary suffix here, alcohol functional group, that is OH functional group, is attached to this carbon atom, so the secondary suffix is ol. Okay, so the name of IUPAC name of this alicyclic compound containing the functional group OH is cyclopentanol. Cyclopentanol. See here, E from the primary suffix ane has been dropped here while writing the name. So the terminal E of ane or ene or yne is dropped when it is followed by the suffix beginning with a, I, o, u or y. So here the primary suffix ane, the terminal e is followed by the suffix beginning with o. For that reason, e has been dropped from this primary suffix ane. Okay, so the name of this alicyclic compound is cyclopentanol. Okay, here is another example. This is an alicyclic compound containing amine functional group, that is NH2 functional group is there. Let us provide IUPAC name for this alicyclic compound. In this ring, 4 carbon atoms are there, so the root word is but, primary suffix is ane because only carbon-carbon single bonds are there, and primary prefix here 4 carbon atoms are forming a ring, so it is cyclo. Next, secondary suffix you can see here, amine functional group is there, so the secondary suffix is amine. So the IUPAC name of this alicyclic compound is cyclobutanamine. Cyclobutanamine. Okay. Next, one more example. Let us see here. This is an alicyclic compound containing ketone functional group. In the case of alicyclic compound, when ketone functional group is there, that carbon atom is the part of the ring only. So here C double bond O is there, and root word 6 carbon atoms are there in the ring, so the root word is hex, primary suffix ane, ane, primary prefix cyclo, secondary suffix ketone, one. So the name of this compound is cyclohexanone. Cyclohexanone. Next, problem number 4. This is an organic compound to which we have to provide the IUPAC name. Solution. This alicyclic organic compound contains ketone functional group. C double bond O functional group is there. And you should always remember one thing. The carbon atom of the ketone functional group is always a part of the ring only. Okay, here. So multiple bond, that is double bond is there, and two substituents have been attached to these two carbon atoms here. First, we have to give the numbers to the carbon atoms in the ring. The priority we should follow while giving the numbers to the carbon atoms in the ring is functional group, that is the carbon atom to which functional group is attached should be given the lowest number as possible. Next, double or triple bonds, finally substituents. Okay, so the carbon atom to which functional groups are attached should be given the highest priority. So for that reason, I am giving the numbers to the carbon atoms in the ring from here, anti-clockwise starting from here. Okay. Next, there are 6 carbon atoms in the ring, so the root word is hex, and there is a double bond between second and third carbon atom here. Primary suffix is "-ine". Primary prefix is cyclo, and secondary suffix here ketone functional group is there, and two substituents methyl groups have been attached to the fifth and sixth carbon atoms, and here ketone means own. So the name of this organic compound is 5,6-dimethyl cyclohex 2-in-1-one. 5,6-dimethyl cyclohex 2-in. Double bond is attached to the second carbon atom, and 1-one ketone group is attached at the first carbon atom here. So this is the IUPAC name of this alicyclic organic compound. Let us further explore some more important rules for naming alicyclic compounds. Rule 1. If the ring contains equal or more number of carbon atoms than the alkyl groups attached to it, it is named as alkyl cycloalkane. Similarly, if the ring contains lesser number of carbon atoms than the alkyl groups attached to it, it is named cycloalkyl alkane. You can better understand this rule by seeing these examples. Here is an example 1. This is an organic compound, and alkyl group has been attached to a ring. Okay, and you can see here the number of carbon atoms in the alkyl group is 5, and the number of carbon atoms in the ring is also 5. So if the ring contains equal or more number of carbon atoms, then the alkyl group attached to the ring should be treated as the substituent. So this one is the substituent. Okay, and the parent name is derived from the number of carbon atoms present in the ring. Substituent, here you can see same number of carbon atoms in the ring and side chain. So the root word is derived from the number of carbon atoms present in the ring. So 5 carbon atoms are there, so it is pent primary suffix ane. There is no secondary suffix. Why? Because no functional group is attached to any carbon atom in the ring. Next, primary prefix cyclo, secondary prefix pentyl. 5 carbon atoms are there in this alkyl group. So the name of this alicyclic organic compound is pentyl cyclopentane. Here is another example. This is an organic compound to which we have to provide the IUPAC name. In this organic compound, one alkyl group has been attached to the ring, and the number of carbon atoms present in the ring is 6, whereas the number of carbon atoms present in the alkyl group attached to the ring is 5. So 1, 2, 3, 4, 5. See here, ring contains more carbon atoms than side chain. This one is a side chain and we must treated it as a substituent. If the ring contains equal or more number of carbon atoms than the alkyl group attached to it, it is named as alkyl cycloalkane. Okay, so this alkyl group attached to the ring should be treated as the substituent. Okay, so in this alkyl group, the second carbon atom is attached to the ring. So see here the root word, we have to derive the root word from this ring. 6 carbon atoms are there in the ring, so it is hex primary suffix ane, primary prefix cyclo, and pentyl. 1, 2, 3, 4, 5 carbon atoms are there in this alkyl group, so it is pentyl. Okay, so second carbon atom in the pentyl group is attached to the ring. So 2-pentyl cyclohexane, the name of this organic compound. Okay. Next, example 3. This is an organic compound to which we have to provide the IUPAC name. And the ring contains 3 carbon atoms, whereas the side chain attached to the ring contains 5 carbon atoms. So 1, 2, 3, 4, 5. In this case, see here, ring contains less carbon atoms than side chain. At that time, we have to consider this ring as the substituent. Okay. If the ring contains lesser number of carbon atoms than the alkyl groups attached to it, it is named cycloalkyl alkane. So we have to derive the parent name from this side chain only. The ring should be treated as the substituent because number of carbon atoms in the ring is less than the number of carbon atoms in the side chain. So the root word 5 carbon atoms are there, it is pent, and only carbon single bonds are there, so the primary suffix is ane. Okay, primary prefix, there is no primary prefix here. Why? Because the carbon atoms in the parent chain is not forming any ring here. And secondary suffix, you can see here, this is the ring which is attached to the carbon 2 here. So here cyclopropyl. The name of this organic compound is 2-cyclopropylpentane. 2-cyclopropylpentane. Cyclopropyl group is attached to the second carbon atom in this parent chain. For that reason, it is 2-cyclopropylpentane. Rule 2. If the side chain contains a functional group or a multiple bond, the alicyclic ring is considered substituent irrespective of the size of the ring. See here, Example 1, under this rule, this is an organic compound containing side chain and a ring. Okay, so the number of carbon atoms in the ring is 4 and the number of carbon atoms in the side chain is also 4. Okay, so the side chain contains multiple bond. Double bond is there here. At that time, irrespective of the number of carbon atoms in the ring should be considered as the substituent only. Okay, so this is the parent chain, and we have to provide the numbers, the carbon atoms in the parent chain starting from right, because multiple bond is there. The carbon atom which is bearing multiple bond should be given the lowest number as possible. For that reason, I am numbering the parent chain from right to left. See here, 1, 2, 3, 4, and this ring should be considered as the substituent only. Okay, and the root word is but 4 carbon atoms are there. Primary suffix here, double bond is there, it is in, and there is no secondary suffix. Why? Because no functional group is attached to any carbon atom in the parent chain, and primary prefix here, see here, there is no primary prefix. Why? Because the parent chain, the carbon atoms, the parent chain is not forming a ring here, and secondary prefix is there, it is cyclobutyl. And this cyclobutyl group, alicyclic group, has been attached to the carbon 4. So 4 cyclobutyl but 1-ene. 4 cyclobutyl but 1-ene. This is the IUPAC name of this organic compound. Here is another example 2 under the same rule. This is an organic compound containing side chain and a ring. The side chain contains double bond and a functional group COOH. Okay, when side chain contains either double bond or triple bond or functional group or both, at that time the side chain should be considered as the parent chain, and we have to derive the root from that parent chain only. And the ring, irrespective of the number of carbon atoms present in the ring, should be considered as the substituent. So here COOH functional group is there. I am taking this chain as the parent chain, and we have to give the numbering to the parent chain, and COOH group is one of the carbon terminating functional group, and at that time the carbon atom present in the functional group must be assigned serial number 1. For that reason, I am numbering the parent chain from right to left like this. Okay, and the ring should be treated as the substituent. Okay, root word, 3 carbon atoms are there in the chain, so it is prop. Primary suffix is double bond is there, so it is in. Secondary suffix you can see here, oic acid. Next, secondary prefix is there because this one is a substituent, so cyclopropyl. The name of this organic compound is 3-cyclopropyl propene oic acid. 3-cycloprop, 2-in-1 oic acid. Actually, third carbon atom in the chain is attached to the cyclopropyl group, and there is a double bond at the second carbon atom. For that reason, 2-in-1 oic acid. So the name of this organic compound is 3-cyclopropyl prop 2 in 1-oic acid. Next, example 3, see here. In this case also side chain contains functional group C double bond O. Functional group is there here. Okay, and the number of carbon atoms present in the side chain is 1, 2, 3, 4, 5. Whereas the number of carbon atoms present in the ring is 6. Irrespective of the number of carbon atoms present in the ring, it should be taken as the substituent only when the side chain contains functional group or multiple bonds. So the side chain contains functional group, C double bond O functional group is there. For that reason I am taking this as the parent chain. Okay, and we have to number the parent chain in such a way that functional group, the carbon atoms attached to the functional groups and the carbon atoms bearing the multiple bonds should be given the lowest numbers as possible. For that reason I am numbering the parent chain from left to right. Okay, so if you number the parent chain from right to left, this carbon atom again gets serial number 3 only, but the double bond gets higher number. For that reason I am numbering the chain from left to right. Okay, now this ring attached to the first carbon atom should be treated as the substituent only. So the root word 5 carbon atoms are there, so it is pent, primary suffix double bond is there, so it is in, secondary suffix C double bond O means it is on. Ketone functional group is there, so it is on. Next, secondary prefix is there, it is cyclohexyl. Okay, so 1 cyclohexyl pent 2 in 3 on. 1 cyclohexyl pent 1 in 3 on. Okay, here the terminal E of the primary suffix is dropped. Why? Because it is followed by the suffix beginning with O. Okay. Next example 4. This is an organic compound containing a ring and a side chain. Here the ring contains a double bond, side chain contains functional group CHO. At that time functional group is given the highest priority than the multiple bonds. For that reason the side chain is taking as the parent chain, and here CHO group is there. It is one of the carbon terminating functional group. At that time the carbon atom in that functional group must be given number 1, serial number 1 while numbering the parent chain. So 1, 2, 3, and this ring is treated as the substituent. Okay, and the root word in this parent chain 3 carbon atoms are there, so the root word is prop. If you compare the number of carbon atoms present in the side chain and in the ring, the number of carbon atoms in the ring is more than the number of carbon atoms present in the side chain. However, the side chain contains functional group. At that time, irrespective of the number of carbon atoms present in the ring, it should be treated as the substituent only. So the parent chain contains 3 carbon atoms, so it is prop, primary suffix only carbon carbon, single bonds are there, it is N, secondary suffix CHO means all. Aldehydes functional group it is, so the secondary suffix is all. Next, secondary prefix you can see here cyclobut 1 enyl. Here in this side chain 4 carbon atoms are there, so it is but, and these 4 carbon atoms are forming ring, so cyclobut, and the double bond, the carbon atoms bearing the double bond should be assigned serial number 1 and 2, or 1 and 2 like this. So 1 enyl. We have known one thing, that when one hydrogen atom is removed from alkanes, we get alkyl groups. Similarly, when one hydrogen atom is removed from alkenes, we get alkenyls. Okay, so in this one hydrogen atom is removed, for that reason it is cyclobut 1 enyl. And this group has been attached to the third carbon atom in the parent chain. So 3 cyclobut 1 enyl propanol. 3 cyclobut 1 enyl propanol. Here E from the primary suffix is dropped for the same reasons explained above. Okay. Next, problem number 5. See here, in this organic compound CH2COOH, one side chain is there and one ring is there. Actually, the ring contains more number of carbon atoms than the side chain. Even though it contains more number of carbon atoms than the side chain, the ring should be treated as the substituent because the side chain contains functional group COOH, and this should be taken as the parent chain, and this parent chain contains the functional group, chain terminating functional group is there. For that reason we should give the number to the carbon atom in the functional group as 1 and 2. And this ring should be treated as the substituent. Okay, root word 2 carbon atoms are there, so it is eth primary suffix, an secondary suffix, oic acid secondary prefix, it is cyclohexyl, and this cyclohexyl group has been attached to the second carbon atom in the parent chain, so 2 cyclohexyl ethanoic acid, 2 cyclohexyl ethanoic acid. Next, problem number 6. This is an organic compound to which we have to provide the IUPAC name. So here side chain is there and ring is there. Side chain contains functional group. For that reason it must be treated as the parent chain. Okay, and this ring should be considered as the substituent, and we have to number the parent chain in such a way that the carbon atom bearing the functional group should be assigned lowest number as possible. For that reason I am numbering the parent chain starting from right to left like this. This is the substituent 1, 2, 3. This is the parent chain. Okay, root word 4 carbon atoms are there, so it is but primary suffix, only single bonds are there, in secondary suffix OH functional group is there, so it is ol, and secondary prefix is cyclohexyl, and this cyclohexyl ring is attached to the third carbon atom in the parent chain. So 3 cyclohexyl, okay, butane 2-ol, 3 cyclohexyl butane 2-ol. Okay. Next, problem number 7. This is an organic compound containing one side chain and a ring. Okay, and the side chain contains functional group. What is the name of this functional group? Can you imagine? It is COOR. Ester's functional group is there. COOR. COOR. Here R means alkyl group. In this case, it is ethyl. So the side chain contains functional group. Hence, it will be taken as the parent chain while naming the compound. And then irrespective of the number of carbon atoms present in the ring, it should be treated as the substituent only whenever the side chain contains a functional group. This is the functional group. Okay. So this ring should be treated as the substituent. The number of carbon atoms in the side chain is only one, COOR. It is one of the carbon terminating functional group. At that time, the carbon atom in that functional group must be assigned serial number 1. So only one carbon atom is there in this side chain. So the root word is meth. Primary suffix is an, secondary suffix. You can see here secondary prefix is substituent, that is cyclohexyl. You can see the secondary suffix here. COOR functional group is there. It means OAT. Okay. So while naming this organic compound, that is while naming esters, the alkyl group present in the functional group COOR, that is R, should be named at first. Okay. In the naming of aliphatic hydrocarbons, aliphatic carbons, I provide all those rules. So here the alkyl group in COOR functional group should be named at first. So ethyl cyclohexyl methanoate. See here, this is the alkyl group. It should be named at first. So ethyl cyclohexyl methanoate. This is the IUPAC name of this organic compound. Next, rule 3. Alicyclic ring is directly attached to the carbon containing functional groups. If an alicyclic ring is directly attached to the carbon containing the functional group, the carbon atom of the functional group is not included in the parent name of the alicyclic ring. Okay. So these are the carbon terminating functional groups: CHO, COOH, COOR, CONH2, C triple bond N, COX. X means halides, fluorine, chlorine, bromine, etc. Okay. So these are the carbon terminating functional groups or chain terminating functional groups. Okay. Here you can see the prefix and suffix names of the carbon containing functional groups. Functional group name, prefix and suffix. COOH, when it is used as the substituent, the prefix name is carboxy, and when it is used as the functional group, main functional group, then the suffix name is carboxylic acid. CHO functional group, the prefix name is formyl, suffix name is carbaldehyde. COOR, esters functional group, when it is used as the substituent, then the prefix name is carboxy or alkyl carbonyl. Suffix name is alkyl carboxylate. Next, CONH2 carbamoyl carboxyamide. Next, C triple bond N, the prefix name is cyno, suffix name is carbonitrile. COX, here hex means halogen elements chloro, fluoro, bromo, iodo, etc. And when it is used as the substituent, then the prefix name is halocarbonyl, and when it is used as the main functional group, then the suffix name is carbonyl halide. Okay, so these are the names of the prefixes and suffixes of carbon containing functional groups. Let us look at some examples under this rule. This is an organic compound in which the alicyclic ring is directly attached to the carbon containing functional group CHO. See here, CHO is one of the carbon terminating functional groups. So, when a carbon terminating functional group is directly attached to the alicyclic ring, in the parent name, the carbon atom should not be included. Okay, so the number of carbon atoms present in the ring only should be taken to give the parent name. The root word in this parent name, root word is pent because 5 carbon atoms are there. Here carbon atom is not included in the parent name. Next, primary suffix, only single bonds are there here. In primary prefix is cyclo, and secondary suffix you can see here CHO functional group is being used in this compound, so the secondary suffix is carbaldehyde. The name of this organic compound is cyclopentane carbaldehyde. Cyclopentane carbaldehyde. Next, example 2. The same way here, the alicyclic ring is attached to the carbon containing functional group CN. Okay, C triple bond N. And in the parent name of alicyclic ring, this carbon atom should not be included. Why? Because this carbon containing functional group is directly attached to the ring. So the root word is pent, primary suffix is ane, primary prefix is cyclo, secondary suffix you can see C triple bond N, and it is used as the functional group. So the secondary suffix is carbonitrile. The name of this organic compound, alicyclic organic compound, is cyclopentane carbonitrile. Cyclopentane carbonitrile. Okay. Next, example 3. Solution. See here. In this alicyclic organic compound, 2 functional groups have been directly attached to the ring. Between these 2 functional groups, we have to select one of the functional groups as the principal functional group, and the other functional group should be treated as the substituent. The selection of the principal functional groups between these 2 functional groups is based on the seniority table. See here, this is a seniority table for the selection of the principal functional group. So here COOR, esters functional group is there, and OH functional group is there. COOR functional group has the highest precedence over the OH functional group. So for that reason, this should be taken as the principal functional group and the OH functional group will be treated as the substituent. Okay. And we have to number the ring in such a way that the carbon atom attached to the principal functional group should be assigned the least or the lowest possible number. So for that reason, I start numbering from here anti-clockwise. Okay. The root word is pent. Primary suffix only single bonds are there in the ring, so it is ane. Primary prefix. These carbon atoms are forming a ring, so it is cyclo. Secondary prefix OH. OH here, when OH functional group is used as the substituent, its name is hydroxy. Next, secondary suffix you can see here COOR. COOR, it is alkyl carboxylate, here methyl carboxylate. Okay, so while naming this organic compound, when COOR functional group is attached directly to the ring, at that time while naming esters, the alkyl group in the esters functional group should be named at first, that is methyl. You see here methyl 2-hydroxy cyclopentane carboxylate. Methyl 2-hydroxy cyclopentane carboxylate. Okay. Next, example 4. This ring is attached directly one of the carbon terminating functional group, here COX, here chlorine is there. Okay. Root word is 4 carbon atoms are there in the ring, so it is but. Primary suffix ane, primary prefix cyclo, secondary suffix you can see here COX functional group is there, carbon terminating functional group is there. So it is the secondary suffix is carbonyl halide, here carbonyl chloride. Carbonyl chloride. The name of this alicyclic organic compound is cyclobutane carbonyl chloride. Next, rule 4, it is one of the most important rules. In case of cyclic ketones, any functional group present in the ring is treated as substituents, even CHO, COH, etc. And keto group is always treated as the principal functional group. This is because carbon of the keto group is a part of the ring. This rule is applicable till the number of carbon atoms in the substituent is less or equal to the number of carbon atoms present in the ring. See here example. This is an alicyclic compound and the ring is directly attached to the two functional groups, ketone functional group and COOH functional group, carboxylic functional group. In this case, when ketone group is attached directly to the ring, at that time that ketone group should be treated as the principal functional group. Actually, between these two functional groups, according to the seniority table, COOH functional group has the highest precedence over the C double bond O functional group. But here ketone group is part of the ring. For that reason, it should be treated as the principal functional group and the remaining functional group even CHO, COOH functional groups are present, they are also treated as the substituents. And this rule is applicable till the number of carbon atoms in the substituent. In this substituent, only one carbon atom is there, and in the ring 6 carbon atoms are there. Okay, so we have to treat C double bond O as the principal functional group and COOH as the substituent. Okay, and numbering is done starting from the ketone functional group carbon atom clockwise. Okay, root word in this alicyclic ring 6 carbon atoms are there. So hex primary suffix "-ane", primary prefix cyclo, secondary suffix here ketone functional group is there. I am taking this as the principal functional group, so it is "-one", and secondary prefix you can see here. Here COOH functional group is considered as the substituent, then prefix name is carboxy, and this substituent is attached to the second carbon atom in the ring. So 2-carboxy cyclohexanone, 2-carboxy cyclohexanone. You can see one more example under the same rule. This is an alicyclic compound containing two functional groups C double bond O and CHO, and in this case also two functional groups are directly attached to the ring C double bond O and CHO. When C double bond O is directly attached to the ring, the carbon atom in it is a part of the ring. For that reason, C double bond O must be taken as the principal functional group irrespective of its precedence in the seniority table. Actually, according to the seniority table, CHO functional group has the highest precedence than C double bond O. But here, the carbon atom in this C double bond O ketone functional group is part of the ring. For that reason, it should be taken as the principal functional group. Okay. And CHO should be treated as the substituent. And we have to number the ring starting from the carbon atom here in this ketone group clockwise. Okay. Root word in this, see here, the ring contains 6 carbon atoms. The root word is hex, primary suffix "-ane", primary prefix is cyclo, and secondary suffix is "-one". C double bond O means "-one", and here CHO is used as the substituent, so the prefix is "-formyl". Okay, "-formyl". Okay, and third carbon atom is attached to this "-formyl" substituent, so 3-formyl cyclohexanone, 3-formyl cyclohexanone. Okay, so far we have seen some of the rules in naming alicyclic compounds containing functional groups. Now I will walk you through some miscellaneous worked examples. Here is example 1. This is an organic compound, alicyclic organic compound, to which we have to provide the IUPAC name. This compound contains only one functional group, ketone functional group is there, and the carbon atom which is attached to the ketone functional group here must be assigned serial number 1, and I am numbering the carbon atoms in the ring starting from here in anti-clockwise direction, because while numbering the ring, functional groups are given the highest precedence, next multiple bonds, finally substituents. For that reason, I am numbering the ring starting from here anti-clockwise. Okay. Root word 6 carbon atoms are there. So the root word is hex. Primary suffix is in because a double bond is there in the ring. And primary prefix is cyclo. Secondary suffix is on. C double bond O is there. It is on. Secondary prefix methyl. So 5 comma 6 dimethyl cyclohex 2 in 1 on. Okay. Next, example 2. In this case, two functional groups are there, COOH and COOR. Ester's functional group is there and carboxylic acid's functional group is there. These two functional groups have been attached directly to the ring. Between these two functional groups, COOH functional group has the highest precedence over this according to seniority table. For that reason, it should be taken as the principal functional group and this functional group will be treated as the substituent. Okay. So, numbering is done starting from this functional group in clockwise direction. Okay. Root word is hex, primary suffix n, primary prefix is cyclo, secondary suffix you can see COOH means carboxylic acid and secondary prefix COOR alkyl carbonyl. It means here C2H5 COOR means R means here alkyl ethyl group is there. So ethyl carbonyl. Ethyl carbonyl substituent is attached to the third carbon atom in the ring. So 3-ethyl carbonyl cyclohexane carboxylic acid. 3-ethyl carbonyl cyclohexane carboxylic acid. Okay. Next, example 3. This is an alicyclic compound containing ketone functional group and 3 substituents, bromine and methyl groups. And we have to number the carbon atoms in the ring starting from ketone functional group carbon atom. Here I am numbering the ring in clockwise as well as anti-clockwise, and which way of the numbering is correct. In order to know that, I will use the lowest set of locants rule. So first I am numbering in clockwise direction and from this carbon atom in anti-clockwise direction. Okay. So which way of numbering is correct? In order to know that, I am using the lowest set of locants rule. Set 1 clockwise locants. 1, here functional group is there. 2 comma 2, that is to the second carbon atom 2 methyl groups have been attached and fifth carbon atom is attached bromine. So clockwise locants are 1 comma 2 comma 2 comma 5. Set to 2 starting from this carbon atom anti-clockwise direction, locants are 1 comma 3 comma 6 comma 6. Now we have to compare these two sets of locants term by term. The first two terms are equal. Then we have to compare the second terms, and 2 is less than 3. So at the first point of difference 2 is less than 3. Hence you no need to compare the remaining terms. So set 1 locants are correct. That is, the clockwise numbering is the right way of numbering and the anti-clockwise numbering is the wrong way of numbering. Okay. So remove them. Now, root word 6 carbon atoms are there, so it is hex. Primary suffix is ane. Primary prefix is cyclo. Next, secondary suffix is one. Okay, ketone functional group is there, it is one. And secondary prefixes are bromine and methyl. Okay, so 5 bromo, 2 comma 2 dimethyl cyclohexane 1 one. 5 bromo 2 comma 2 dimethyl cyclohexanone or hexane 1 one also you can write, no problem. Okay. Next example 4. See here. In this alicyclic compound C triple bond N, one carbon terminating functional group is there. Okay, and 2 methyl groups have been attached here. So we have to, this is the functional group, we have to start the numbering from here and give the numbering in clockwise direction. Okay, so root word is but, 4 carbon atoms are there. Next, primary suffix is ane, primary prefix is cyclo, and secondary prefix is methyl. 2 methyl groups have been attached to the second carbon atom in the ring. And C triple bond N suffix is carbonitrile, secondary suffix. Okay, so 2 comma 2 dimethyl cyclobutane carbonitrile. 2 comma 2 dimethyl cyclobutane carbonitrile. Next, example 5. In this alicyclic compound, one substituent is there and multiple bond, triple bond is there. No functional group is present in this. Okay, so when alicyclic ring contains multiple bonds without functional group, the carbon atoms bearing the multiple bonds must be assigned 192 numbers consecutively. Okay, so for that reason I am numbering the ring starting from here, and next preference should be given the substituents while numbering. For that reason I am numbering these 2 carbon atoms 1 and 2 in anti-clockwise direction. Numbering is done. Okay, so root word is 6 carbon atoms are there in the ring, so the root word is hex. Primary suffix triple bond is there, so it is ine. Next, primary prefix is cyclo. There is no secondary suffix. Why? Because no functional group is present. Next, methyl, secondary prefix, substituent is there. So methyl group is attached to the third carbon atom. So 3 methyl cyclo hex 1 ine. 3 methyl cyclohexane or cyclohex 1 ine also you can write. Next, example 6. In this organic compound, alicyclic organic compound, one functional group, carbon containing functional group CHO is there, and 2 substituents have been attached. And these 2 substituents, bromine and methyl group, both are competing for the same number. Okay, so at that time we have to give the lowest number to the substituent which comes first in alphabetical order. So for that reason I am numbering the ring starting from this carbon in clockwise direction. So root word is hex, primary suffix is ane, primary prefix is cyclo, secondary prefixes bromo and methyl, secondary suffix, you can see CHO functional group is there. When CHO functional group is there, and secondary suffix is carbaldehyde. So the name of this alicyclic organic compound is 2-bromo 6-methyl cyclohexane carbaldehyde. 2-bromo 6-methyl cyclohexane carbaldehyde. Next, example 7. This is an organic compound containing three functional groups. Three functional groups have been directly attached to the ring C double bond O, COOH and CHO. I already told you in our previous examples, when ketone group is attached to the ring directly, then that functional group must be taken as the principal functional group because the carbon atom in that functional group is a part of the ring, and the remaining functional group must be treated as the substituents irrespective of their seniority in the seniority table of functional groups. Okay, so this one is the principal functional group, so this carbon atom must be assigned 1, serial number 1, while numbering the ring, and we can give the numbers either in clockwise or anti-clockwise. So first, see here, numbering is being done in clockwise. If anti-clockwise numbering is done according to the lowest set of locants rule, you see here 1, 2, 5. 1, 2, 5 are the locants. If anti-clockwise numbering is done, 1, 3, 6 are the locants. If you compare the terms, anti-clockwise numbering is the wrong way of numbering and clockwise numbering is the right way of numbering. So here root word is hex, primary suffix is ane, primary prefix is cyclo. Here COOH and CHO both are using as the substituents, so carboxy and formyl. Okay, next, C double bond O is the principal functional group. It is secondary suffix is -one. Okay, the name of this organic compound is we have to write the substituents according to the alphabetical order. So carboxy comes first, so 2-carboxy 5-formyl cyclohexanone. Next, problem number, otherwise example 8. This is an organic compound, alicyclic compound containing multiple bonds but no functional groups. Only substituents are there. So when an alicyclic ring contains multiple bonds without functional groups, the multiple bond, the carbon atoms bearing the multiple bond must be assigned serial number 192 continuously. So we can give the numbering to the carbon ring starting from here anti-clockwise or from starting here clockwise. So which way of numbering is correct? In order to know that, we have to use the lowest set of locants rule. So I am giving the numbering starting from here 192 to the multiple bond carbon atoms clockwise, and starting from here I can give the numbering in anti-clockwise also. Which way of the numbering is correct? To know that, let us use the lowest set of locants rule. Set 1 clockwise locants are, see here, 1, the first carbon atom is bearing the substituent, that is methyl group, and 6th carbon atom. So 1, 6 are, these are the locants. Set to anti-clockwise locants 2, 3. If you compare these two sets of locants term by term, At the first point of difference, 1 is less than 2, then you no need to compare the next terms. So at the first point of difference, 1 is less than 2. That means clockwise numbering is the correct way of numbering. This one is the wrong way of numbering. Okay. So root word is hex, primary suffix is in because double bond is there, and there is no secondary suffix as no functional groups are present in this. Primary prefix is cyclo and methyl. So 1 comma 6 dimethyl cyclohex 1-ene. Next, example 9. This one is the last example in this video. This is an alicyclic compound containing one functional group, OH functional group, and 3 substituents, bromine and 2 methyl groups. Okay. We have to number the ring in such a way that the carbon atom attached to the functional group should be assigned the lowest number possible. So this carbon atom, starting from this carbon atom, numbering can be done either in anti-clockwise or in clockwise. So I am numbering the ring starting from this carbon atom in anti-clockwise direction at first, then starting from the same carbon atom in clockwise direction. So which way of numbering is correct? To know that, we have to use the lowest set of locants rule. Set 1 anti-clockwise locants are 1, 3, 4, 4. Set 2 clockwise locants are 1, 4, 4, 5. Now we have to compare these two sets of locants term by term. At the first point of difference, you see here the first two terms are equal, then compare the next terms. Here 3 is less than 4, so at the first point of difference 3 is less than 4, so no need to compare the remaining terms. So anti-clockwise numbering is the correct way of numbering and the clockwise numbering is the wrong way of numbering. Okay. So the name of this alicyclic organic compound is, we have to write the substituents according to the alphabetical order. So bromine comes first. So 3 bromo 4, 4 dimethyl, okay, cyclohexanol. 3 bromo 4, 4 dimethyl cyclohexanol. Okay, so that's all for this video and thank you very much.